All right, today we are cracking the code on microservices. This is a huge shift in software design, and it's what powers giants like Netflix and Amazon. We're going to break down what they are, sure, but more importantly, we'll get into the core patterns that actually make them work, and the critical trade-offs you absolutely need to understand before even thinking about diving in. So let me ask you this. Have you ever been on a project where everything is powered by one giant, tangled application? You know the one, where fixing a tiny bug over here somehow breaks a totally unrelated feature way over there. Yeah, that's the world of the monolith, and it's the exact problem that microservices were created to solve. Here's the best way to think about it. A monolith is kind of like one of those pre-molded plastic toys. It does its one thing, and that's it. You can't really change it. But microservices? They're like a giant box of Legos. You get a whole collection of small, independent, reusable bricks that you can combine in a million different ways to build something really powerful and, most importantly, flexible. To really get why this new way is such a big deal, we have to first understand the limitations of the old way. So let's take a closer look at the challenges that come with that single, rigid block. Okay, this is where you really see the difference. Deployments. With a monolith, if you want to update one tiny little feature, you have to redeploy the entire application. It's this high-stakes, all-or-nothing event. With microservices, you just update the one small service, that one Lego brick, that needs changing. And that makes managing change so much simpler, way faster, and a whole lot less risky. So, we've seen the problem. Now, let's really dig into the philosophy behind the solution. What are the big ideas that make microservices so fundamentally different? This definition from Martin Fowler is pretty much the perfect place to start. The keywords here are small services and own process. It's all about breaking one giant application into a team of independent specialists that all know how to work together. At the very heart of this whole thing is something called the single responsibility principle. This is the golden rule right here. An order service should only ever handle orders. A customer service only manages customers. That's it. Each one is its own self-contained unit with a super clear purpose and, this is key, it owns both its business logic and its own data. And when you follow that rule, you get some seriously powerful benefits. Take scalability. You can scale up just the one service that's getting hammered with traffic, not the whole app. Or failure isolation. If your recommendation service goes down, who cares? Your users can still place orders. It just helps you build a much more resilient and flexible system from the ground up. Okay, the philosophy is great, but how do we actually build this stuff? So now, let's shift gears and talk about the practical, proven patterns that make a microservices architecture actually work in the real world. And this brings us to our first huge hurdle. Think about it. If all your services are supposed to be independent, but they all talk to the same single database, are they really independent? The answer is a hard no. So, what's the fix? The solution is this beautiful pattern called database per service. It's simple. Each microservice gets its own private database. The order service is not allowed to directly touch the customer database. This enforces true independence, and it unlocks this superpower called polyglot persistence. All that means is you're not stuck with one kind of database anymore. Your transaction service can use a super reliable relational one, while your product catalog uses a blazing fast NoSQL database. You always get to use the right tool for the job. Now, that's great for new projects, but let's be real. What about that giant monolith you already have? A complete rewrite is incredibly risky and can take years. There has to be a safer, more gradual way to make that switch. And there is. It's called the strangler fig pattern, which is just a fantastic name. So just like a vine that slowly grows around and overtakes a tree, you don't do a risky big bang rewrite. Instead, you build new services around the old monolith, piece by piece. You slowly redirect traffic to the new service, and once you're sure it's working, you can finally turn off the old piece. Your new microservices are literally that strangler fig vine, just gradually wrapping themselves around the old monolith. Over time, as more and more of the logic moves to the new services, the monolith just shrinks. And eventually, with nothing left to do, it can finally be retired for good. It's a low-risk, step-by-step way to modernize. All right, so we've built our services, and we're slowly migrating our monolith. But this new distributed world creates a whole new class of challenges. When you've got dozens of services all chattering with each other, you have to build for failure. That's the secret to resilience.
Just think about a super common scenario. A customer places an order. Okay, that might involve the order service, the customer service to check their credit, and the inventory service to reserve the item. All three of those things have to work perfectly. If just one of them fails, the whole transaction has to be completely undone. How on earth do you manage that across separate distributed services?
The answer is another pattern called the saga. A saga is basically a sequence of local transactions. First, the order service creates the order. Then it triggers the customer service to reserve credit. If any step fails along the way, the saga kicks off these compensating actions, like refunding the credit, to undo everything and make sure the data stays consistent.
Now, there are two main ways to pull off a saga. Take a look at the diagram on the left. That's called choreography. Here, the services just talk to each other through events. The order service just yells, "Hey, an order was created," and the customer service knows to listen for that and do its job. It's decentralized, it's pretty simple for a few services, kind of like a well-rehearsed dance. Now look at the one on the right. That's orchestration. Here you have a central conductor, an order controller. It tells each service exactly what to do, step by step. You, order service, create the order. Next, you, customer service, reserve the credit. It's more complex to set up, for sure, but it's way easier to manage when your process has a whole bunch of steps.
Here's another really scary problem. What happens if one service starts to get slow or just completely fails? Well, if all the other services keep hammering it with requests, they might get stuck just waiting, and that delay can ripple through the entire system and cause a cascading failure, a total meltdown. To stop that from happening, we use the circuit breaker pattern, and it works exactly like the one in your house's fuse box. It basically wraps the calls going to another service and keeps an eye on them. If it sees too many failures in a row, the circuit trips, and it immediately fails any new requests without even bothering to call the broken service. This protects the whole system and gives that struggling service some breathing room to recover. So we've gone through the philosophy and some essential patterns. But what's it really like, day to day, living in a microservices world? It's not a magic bullet. It is a series of trade-offs. Now, the reward for all this complexity is huge. You get the power to scale only the parts that need it, the freedom to pick the best technology for every single job, the speed to deploy updates constantly, and you get a system that can handle parts of it failing without the whole thing crashing down. But, and this is a big but, that reward comes at a cost. Here is the single most important trade-off you need to understand. You are exchanging a complex application for complex operations. Instead of one big thing to manage, you now have dozens, maybe hundreds. You have to deal with network lag, and trying to debug a problem that crosses 5 different services is a whole new kind of headache. So in the end, the most important question isn't, are microservices good? It's, are we ready for them? Is your team, is your organization prepared to handle the operational complexity that comes with all that power and flexibility? That right there is the real question.